In this video, we're going to take a look at naming amines. And naming amines kind of goes by the rules that we've seen up to this point. So all we're going to be doing is counting atoms from the functional group, just like we've done in the past. So for example, if I have two carbon atoms and then a nitrogen, like this, lone pair on there, and I didn't put on the other hydrogens because I'm just lazy. Okay, so this here is a primary amine because there's only one of these hydrogens substituted with a carbon. And we might recognize here we've got two carbons like this, we've got two carbons, and so that should be an ethyl group. Okay, so this here would become ethyl amine. Ethyl amine, okay? And if say, for example, then we had, a secondary one here like this. Secondary like this, okay? Well, then now this would become, let's see here, we've got methyl, we've got methyl. So this would become dimethylamine. Dimethylamine. Okay, now, what if then we have something else? So if I have 4 carbon atoms, 1, 2, 3, 4 carbon atoms like this, I have my amine group. And then I have a substituent here like chlorine. Okay, so I'm going to number this starting with my amine here. So this becomes 1, 2, 3. So it becomes 3-chloro. 3-chloro. And then to show that the amine is off of the first carbon, I'm going to go 1, and then 1, 2, 3, 4. This is butan amine. 3-chloro, 1-butan amine. Well, what if we have 2 amine groups on? Well, let's try that. Let's put another amine group over here. We'll go like this, and NH2. Okay, so now on this one here, now we've got 2 amines on like this, so this becomes 1,4-butan diamine. Butan diamine. Okay, so this up to this point has been primary amines for the most part. So what happens if you have a secondary amine, like multiple things coming off of that nitrogen atom that are different substituents? So let's take a look at that. So if I have, say, a nitrogen atom like this, I'll go NH like this, okay, and then I'll go CH3, and then coming off of that, CH, and then CH3, and then CH2, 2, and CH3, like this. Okay, so I've got 2 substituents coming off of that nitrogen atom there. So to show what's coming off of the nitrogen atom, we'll use the letter N. And so we're going to say N-methyl. And that's saying that the methyl group is attached to the nitrogen atom. So N-methyl. And then this long chain here, this here is 1, 2, 3, 4. So that's butane. And the nitrogen's coming off of the second carbon. Okay, so it's 1, 2. And I'm just going to number this going from right to left. See, 1, 2, instead of from left to right, because then I end up with a smaller number, is all. Okay, so this then becomes 2-butan amine. And what if we have, let's try something else, another two things coming off of that nitrogen atom here. Let's try two things coming off of that nitrogen atom. Let's try carbon, and then carbon, and then let's try like this. Okay, so now we have our longest chain here. Our longest chain is propane, so our base or root of this is going to be propane amine. Propanamine, and we have here a couple of methyl groups coming off of it. And so we would say N dimethyl 1-propanamine. Okay, so the NN is telling us that the methyl groups are attached to the nitrogen, and then the 1-propan is telling us that this nitrogen is attached to the first carbon of the propane group here. And then the whole thing is an amine because we have that nitrogen coming off of there like that. Okay, now there are situations where we have the nitrogens as a substituent. In other words, it's just kind of like hanging off on the side of the molecule. And when that happens, we call it an amino. And so if we have, say, a carboxylic acid, like 1, 2, 3, 4, 5, like this, okay? We might recognize this here as pentanoic acid. Pentanoic acid. But then what happens if we throw an amine on there, like this? Go NH2. Okay, so how would we name something like this? Well, now the amine is a substituent. And so we would say that the base or root of this is pentanoic acid. And we start from our functional group here and go 1, 2, 3. Okay, so off of the third carbon is our amino group. So this becomes 3-amino pentanoic acid. And there'd be no space here between the amino and the pentanoic acid. And then one last thing here is sometimes we have benzene rings with an amine group, or well, an amino group attached onto it. So if we have a benzene ring, benzene ring like this, with our amino group like this, this has a fancy name. This is called aniline. Aniline. And so if we had, say, a bromine attached like this, then this here might be M-bromo-aniline, and that's to say it's in the meta position. Meta position is like carbon, 2 carbons apart like this. And if that bromine was, say, here in this position right here, then that is in the para position. Okay, so this would become P-bromoalanine. Now that we've gotten enough organic chemistry to be dangerous, I'm going to write out the name of a molecule here and see if we can't do the structure. Okay, so this one here is going to be 1 phenyl propan 2-amine. Okay, and the other one we're going to try here is N-methyl 1-phenyl propan 2-amine. Okay, N-methyl 1-phenyl propan 2-amine. Okay, there's a lot going on there. Now, if you want a challenge, you just pause the video at this point and try drawing it out. Or you just follow along. Okay, so let's give this one a try. 1-phenyl propan 2-amine. All right, so propan tells me there's 3 carbons. And with 3 carbons now, it's telling me off of the second carbon, I have an amine. So let's try this. We're going to do carbon, carbon, carbon. There's my propan. And then coming off of the second one here is going to be my amine. Okay. And then it says coming off of the first carbon is my phenyl group. And remember, phenyl is just a fancy name for a benzene ring, like that. Okay, now this one has another name, this 1-phenyl propan 2-amine. The other name for this molecule is amphetamine. Okay, so now here we have N-methyl 1-phenyl propan 2-amine. Well, that seems very similar, does it not? So we have this propan 2-amine. So I'm going to go carbon, 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 okay? And off of the second carbon is my amine. Okay, and then coming off of that, let's see here, I've got a phenyl coming off of the first carbon. So phenyl coming off of first carbon like that. And then I have N-methyl. And so this tells me that there's a methyl group coming off of that nitrogen. So I'm going to change one of these hydrogens here, just swap that out there. And then I'm going to put in a methyl group here, CH3. So that becomes N-methyl 1-phenyl propan 2-amine. And so what's the difference between these two? This is amphetamine. This here is methamphetamine, or sometimes just called meth. Wow, now I know enough organic chemistry to be dangerous.